Have you ever felt like you're wading through this mountain of like tech jargon just to understand the basics of .NET?
Yeah, it can definitely feel overwhelming, right? All
Yeah,
those terms and concepts can be a bit intimidating at first.
totally. And that's why we're here today for this deep dive. We're going to get to the core of .NET. And the cool part is we're using the awesome questions that you, our listeners,
It-
sent in.
Yeah, it's like a guided tour based on exactly what you want to know. It's going to be super practical.
Absolutely. So we've got these questions that cover a huge range of .NET topics. We've got everything from ASP.NET request pipelines to, the ins and outs of LANQ.
All those little things that can trip you up or make you go, huh?
Exactly. And
Yeah.
our mission here is to, extract those really valuable insights from these questions and answers and clarify those key differences between things.
And like really show you how these concepts actually work in practice so that you can, save yourself some time and avoid those headaches.
Right, because who wants to spend hours digging through documentation when you can just get those aha moments right here?
Absolutely.
Okay, so let's kick things off with the ASP.NET lifecycle. Now, I know this can sound a bit, intimidating or like a really complex process, but at its heart, what's actually happening when, a user visits a website built with ASP.NET? What's going on behind the scenes?
So think of the ASP.NET lifecycle as a journey. It describes exactly what happens from the moment a user requests, like a web page, types in a URL, clicks a link, all the way to the point where that page actually appears in their browser.
Oh, that's a helpful way to visualize it.
And the questions you guys sent in actually highlight two really important parts of this life cycle: the application life cycle and the page life cycle.
Right. I was going to ask about that. Are those like two separate things or are they like connected?
They are definitely connected. So the application life cycle, you can kind of think of it as like the big picture setup. It's how the whole ASP.NET application starts up, initializes all its components, and gets ready to handle those incoming requests.
Okay, so it's like the engine starting up and then
Exactly. And then when a specific page within that application is requested, that's when the page lifecycle kicks in. This is more granular. It's all about that individual page, how it loads, processes, and ultimately renders itself for the user.
got it. So the application is kind of like the framework, and
Yeah.
the page is the specific content within that framework. Now, in terms of the page lifecycle itself, what are the key stages that a page goes through?
Yeah, so the major fuses, there's the initialization phase where the page kind of gets itself ready, right?
Like setting up the environment and
Exactly. It's figuring out what it needs, getting everything in order. Then there's this really interesting phase called restoring the view state.
what's that all about?
So, view state is this mechanism in ASP.NET that allows a page to remember things from the user's previous interaction, like if they filled out a form or selected certain options.
Ah, so it's like saving their progress, even if they haven't like officially submitted anything?
Exactly. And this restoring phase is about bringing back that saved information so the page can kind of pick up where it left off. Then comes the execution phase, which is where your actual code runs, all the logic, the database interactions, whatever your page is supposed to do.
Right, that's where the action happens.
And finally, we have the rendering phase, where the page takes all that processed information and translates it into HTML, the language of the web.
So that's what actually gets sent back to the browser for the user to see.
Exactly. It's like taking all the ingredients, mixing them up, and then presenting that final dish.
Okay, I'm getting hungry now.
Me too.
So the application lifecycle sets the stage, and then each individual page goes through this initialization, restoration, execution, and rendering cycle every time a user interacts with it. That makes sense. Okay, let's move on to something that sounds a little less, life cycle-ish. Let's talk about yield.
But a yield.
Now, this seems like one of those C# keywords that can be kind of mysterious at first.
Yeah, definitely.
So what is yield all about, and why should we care? The source materials mention it's a clever way to manage memory, especially when dealing with, large collections of data.
It's all about efficiency. Think of it like this. Imagine you have a huge library full of books, but you only need to read one book at a time. Would you carry the entire library with you everywhere?
No way, that's way too heavy.
Exactly. That's kind of what traditional methods do sometimes. They try to generate all the results at once before returning anything. But yield is smarter. It's like checking out one book at a time, reading it, and then returning it before getting the next one.
So instead of creating this massive collection in memory, yield lets you generate items one by one, only when they're actually needed.
Exactly. And this can save a ton of memory, especially when you're working with, huge data sets.
Okay, so that's the what. What about the how? How do you actually use yield in your code?
So you use the keywords yield return within a special kind of method called an iterator method. This method returns an IEnumerable sequence, which is essentially a collection of items that can be iterated over. But instead of generating all those items up front, the yield return statement kind of pauses the method, hands out one item, and then remembers where it left off.
So it's like a bookmark in the code. It remembers its place and picks up where it left off when it needs to generate the next item.
Exactly. And this on-demand generation is what makes yield so powerful for memory management. It's a real game changer for writing efficient code, especially when dealing with those massive amounts of data.
Okay, so it's a small keyword, but it has a really big impact. I like it. All right, next up is something that I think a lot of people struggle with. Understanding the difference between events and delegates.
Ah, yeah, events and delegates.
They seem to be like, intertwined concepts, but it's not always clear what distinguishes one from the other.
It's a classic source of confusion. They are definitely related, but they play distinct roles in .NET.
So to get started, can you just explain in simple terms what each of these is? What's an event and what's a delegate?
Okay, so a delegate, you can think of it as like a blueprint for a method. It defines the shape of a method, its parameters, its return type, without actually containing any code itself. It's more like a placeholder or a reference that you can point to a specific method later on.
Okay, so it's like a contract that says, hey, this is what this kind of method looks like.
Exactly. And an event is, well, it's like a mechanism that uses delegates to, notify other parts of your code when something interesting happens.
Like an announcement.
Yeah, exactly like an announcement. When an event occurs, it's like shouting, hey, this thing just happened. And any part of your code that's interested in that event can subscribe to it. When the event is raised, those subscribers get notified and can respond accordingly.
Okay, so the delegate is the format, the structure, and the event is the actual occurrence, the announcement using that structure. That makes sense. Now, the source material we've been digging into highlights some key differences between these two. One of the things that caught my eye is that delegates can be passed as parameters to methods, but events can't. Why is that?
That's because a delegate is a type. You can think of it as, like a variable that holds a reference to a method. So just like you can pass any other variable as a parameter, you can pass a delegate. An event, on the other hand, is more like a member of a class. It's not designed to be passed around as a value itself.
Okay, so it's like the delegate is a movable piece of data, whereas the event is more like a fixed feature of the class it belongs to. Another difference mentioned in the source is that events can be overridden, but delegates can't. What does that mean in practice?
Overriding is, like a core concept in object-oriented programming. It's about providing a more specific implementation in a derived class. Now, events, being members of a class, they can participate in this whole overriding thing.
Right, you can use those override and virtual keywords to customize their behavior in subclasses.
Exactly. Delegates, however, they're just type definitions. They're not really part of the inheritance hierarchy, so they don't have this whole concept of overriding.
Okay, so it's like events are part of the class structure and can be customized through inheritance, but delegates are just blueprints that exist independently. And then there's this. Events can't exist without delegates, but delegates are independent. That seems to reinforce this built on top of idea.
Yeah, that's a really good point. You can't have an event without a delegate because the delegate defines the signature of the methods that can handle the event. It's like the delegate is the mold and the event is the specific object created from that mold.
So it's like you're saying, hey, I have this event, and here's the shape of the methods that can respond to it, and that shape is defined by the delegate.
Exactly. You could have a delegate without an event, but not the other way around.
Okay, that clarifies that. Another difference we see is about where they're defined. Delegates are declared outside a class, events inside. Why is that?
So delegates, as we said, they're like blueprints, right? And these blueprints can be used in lots of different places across different classes. So it makes sense for them to be declared outside of any specific class. Events, on the other hand, they're tied to a specific class because they represent something that happens within the context of that class.
So delegates are more general purpose, and events are specific to what's going on within a particular class. Okay, two more points of comparison here. First, delegates support covariance and contravariance, but events don't. What's the deal with those?
Covariance and contravariance are, they're kind of advanced concepts. They're all about how flexible you can be with the types of parameters and return values when you're working with delegates. Delegates have this flexibility Events don't need it as much because they're focused on that signaling within a class.
So it's like delegates have more advanced typing options, which isn't really necessary for events.
Right.
And then finally, and this one seems really practical in terms of potential pitfalls, delegates use the assignment operator while events use plus. Why is that potentially dangerous?
Yeah, this is a really important one. When you use with a delegate, you're essentially saying this delegate now only points to this one method. But the problem is, if other parts of your code have also attached their methods to that delegate, you're essentially wiping them out, disconnecting them.
So it's like cutting off all the other subscribers.
Exactly. Events, on the other hand, they use this plus operator, which is a much safer way to add a subscriber to the list. You're not overwriting anything, you're just adding to the group.
So plus for adding a subscriber and one for removing one. That makes sense. It's about preventing one part of your code from accidentally breaking the notifications for everyone else. Okay, that really clarifies a lot about events and delegates. Let's move on to something called attributes.
Okay, attributes.
Now, I like how the source material describes them as metadata magic. What's so magical about them? What do they do?
Yeah, metadata magic is a good way to put it. Attributes allow you to add extra information or metadata directly to your code. Think of it like, adding labels or tags to your classes, methods, or even to the entire assembly.
Okay, so it's like adding notes or annotations to your code.
Exactly. And this metadata doesn't actually change how your code runs directly, but it provides valuable context that other parts of the system can use.
Interesting. What kind of other parts of the system?
So, for example, the compiler can use attributes to understand how to generate the executable code. Or the .NET runtime can use attributes to make decisions about how to execute your code at runtime.
Okay, so it's like giving instructions or hints to the compiler and the runtime.
Exactly. And you can even use attributes in your own code to, add custom behavior or implement certain patterns.
Okay, that sounds powerful.
Yeah.
Can you give us some more concrete examples of how attributes are actually used in the real world? The source material mentions a few.
Yeah, so one common use is for documenting your code. You can use attributes to provide descriptions for your classes and methods, so when someone else is looking at your code, they can easily understand what everything does.
Ah, so it's like built-in documentation that's right there in the code.
Exactly. And you can also use attributes to enforce coding standards. Like, you could create a custom attribute that says, hey, this method should only be called from within this specific class, and then you could have a tool that checks your code to make sure that rule is being followed.
Oh, so it's like adding guardrails to prevent certain kinds of coding mistakes. That's really interesting.
And then there's a really cool thing called reflection, which is the ability to examine your code at runtime. And attributes play a big role in reflection.
Reflection. We've seen that term mentioned before, but what is it exactly?
Reflection is like giving your code the ability to look at itself in a mirror. It can see its own structure, its methods, its properties, and importantly, the attributes that are applied to all those things.
So it's like code that can introspect and understand itself.
Exactly. And this can be incredibly powerful because you can write code that makes decisions based on the attributes it finds. Like, a framework might use attributes to figure out how to serialize an object into a specific format or how to map a class to a table in a database.
Wow, so it's like adding this extra layer of meaning to your code that other parts of the system can use to make intelligent decisions.
Yeah.
That's really cool. Okay, let's switch gears a bit and talk about dynamic versus object. Now, in the programming world, we usually talk about strong typing, right? Where you have to specify the exact type of a variable. So what's the deal with dynamic and object? When would you actually use those?
So you're absolutely right that C# is generally a strongly typed language, meaning that you normally have to declare the type of a variable before you use it. But there are some situations where you might not know the exact type of a variable at compile time.
Can you give an example? When wouldn't you know the type ahead of time?
Yeah. So imagine you're interacting with like a web service that returns some data, but you don't know exactly what the structure of that data is going to be. Or maybe you're working with a dynamic language like Python where the types can change at runtime.
Okay, so it's like dealing with unpredictable or unknown data sources.
Exactly. And that's where dynamic and object come in.
So what's the difference between the two?
Object is the most general type in .NET. Every single type in .NET ultimately inherits from object. So you can assign any value to a variable of type object. But when you do that, you lose type safety. You can't access the members of that object directly without casting it back to its specific type.
Right, because the compiler doesn't know what methods or properties are available until runtime.
Exactly. And dynamic is kind of like a more powerful version of object. It also lets you bypass compile time type checking, but it does this through something called dynamic dispatch.
Dynamic dispatch. Sounds complicated.
It is a bit under the hood, but the basic idea is that the actual type of the dynamic variable is figured out at runtime. And then when you call a method or access a property on that variable, the .NET runtime figures out which method to actually execute based on the object's real type.
So it's like it defers the decision about which method to call until the last possible moment.
Exactly. And this can be super flexible, but it also comes with some risks. You lose the compile time safety net, so if you make a mistake, you won't find out until your program crashes at runtime. Oh.
Oh, that's a good point. So dynamic is powerful, but requires careful handling. Okay, let's shift gears again and talk about designing classes. Interface versus abstract class. These seem like they're both ways of defining a template for a class, but what are the key differences? When would you use one over the other?
Yeah, that's a really fundamental question in .NET development. Both interfaces and abstract classes are used to achieve abstraction to define a kind of blueprint for a class. But they have some pretty important differences.
Like what?
Let's start with inheritance. A class can implement multiple interfaces, but it can only inherit from a single abstract class.
Oh, right, because C# doesn't support multiple inheritance for classes.
Exactly. Interfaces are like contracts. They specify a set of methods that a class must implement. A class can agree to fulfill multiple contracts. An abstract class is more like a base class that provides some basic functionality, and a class can only have one base class.
Okay, so it's about how many parent blueprints a class can have. Multiple interfaces, but only one abstract class. What else?
Another key difference is in how they define members. Interface members are always public, whereas abstract class members can have any accessibility, public, private, protected.
Why is that?
Interfaces are all about defining a public contract, what methods are available to other classes. Abstract classes are more about providing a base implementation that derived classes can build upon so they can have internal or protected members that are only used within the class hierarchy.
So interfaces are like public APIs, and abstract classes are more for internal structure.
Exactly. And then there's the question of implementation. Interface methods don't have any implementation. They just define the signature, the name, parameters, return type. Abstract classes can have methods with or without implementation.
Right, so if you have an abstract method, the derived class has to provide the implementation. But if you have a concrete method, the derived class can either use it as is or override it with its own version.
Exactly. And then there's the fact that interfaces can't have constructors, but abstract classes can.
Constructors. Those are the methods that are called when you create a new instance of a class, right?
Exactly. Interfaces don't have constructors because they don't define any state, no fields or properties. Abstract classes can have state, so they need constructors to initialize those fields.
And then finally, interfaces can only have methods, properties, events, and indexers, whereas abstract classes can have fields as well.
Right. It all boils down to the fact that interfaces are for defining contracts, while abstract classes are for providing a base implementation. So the choice of which one to use really depends on what you're trying to achieve.
Okay, that was a lot of information, but it's super helpful to understand those key differences. Now, let's move on to something a bit more concrete, how we store collections of data in C#. We've got two popular options, linked list and list.
Yeah, linked lists and lists. They're both ways of storing sequences of items, but they have different performance characteristics for different operations.
Like what?
Well, first off, there's thread safety. The list class in .NET has built-in mechanisms to help manage concurrent access from multiple threads, which can be really important in, multi-threaded applications. Linked list lead doesn't have these features built in, so you'd have to handle thread safety yourself.
Okay, so list is generally safer to use in multi-threaded environments.
Right. And then there's the memory overhead. Linked list generally uses more memory per element because each node in the list has to store references to both the previous and the next node, which can add up.
So if you're really concerned about memory usage, list might be a better choice.
Right. But linked list has an advantage when it comes to inserting or removing items in the middle of the list. In a list, if you insert or remove something in the middle, you have to shift all the subsequent items to make room, which can be a bit slow if the list is large. But in a linked list, you just have to update the pointers of the surrounding nodes, which is much faster.
So linked list is better for frequent insertions and removals, especially in large lists.
Right. But list is faster for accessing items by their index because it's just an array under the hood, so you can directly access any element. In a linked list, you have to traverse the list from the beginning or end to find the element you're looking for.
So it really depends on how you're going to use the collection.
Exactly. If you're primarily going to be adding and removing items in the middle, linked list might be a better choice. But if you need to quickly access items by their index, list is usually faster.
Okay, that's a really clear breakdown of the trade-offs. Now let's dive into the world of LINQ, Language Integrated Query. We've got two key interfaces here, IEnumerable and iQueryable.
LINQ is super powerful for working with data, and these two interfaces are essential to understanding how LINQ actually works.
So what's the difference between them? They both seem to be ways of representing sequences of data, but the source material hints at some really important distinctions in how they handle that data.
The key difference is where the query is actually executed. With IEnumerable, the query is executed in memory on the client side. With iQueryable, the query can be translated and executed on the server side, for example, in a database.
Oh, that's a big difference. Why would you want to execute the query on the server side?
For performance reasons, mainly. Imagine you have a huge table in a database, and you only want to retrieve a few rows that meet specific criteria. If you use IEnumerable, your application might end up downloading the entire table into memory just to filter it, which is obviously very inefficient.
Right, because you're bringing all the data over the network and then processing it locally.
Exactly. But with iQueryable, you can actually send the query to the database server, where it can be executed much more efficiently using the database's own indexing and optimization capabilities. So only the results that you actually need are sent back to your application.
Ah, so it's like offloading the heavy lifting to the database.
Exactly.
And the source material mentions that iQueryable is particularly useful for something called LINQ to SQL.
Yes. LINQ to SQL is a technology that allows you to write LINQ queries against a SQL Server database. And iQueryable is what makes that possible because it provides the mechanism for translating those LINQ queries into SQL statements that can be executed on the server.
So iQueryable is like a bridge between LINQ and the database.
Exact.
Okay, that makes a lot of sense. And then finally, there's this concept of lazy loading and paging, which are really important for performance when dealing with large data sets. The source material mentions that iQueryable supports these things, but IEnumerable doesn't in the same way.
That's right. Lazy loading means that data isn't actually retrieved from the data source until you actually need it. And paging is about only retrieving a subset of the data at a time, like showing 10 results per page. And iQueryable can support these features because it's working with the database directly. It can send queries to the database that say, hey, only give me these specific rows, or hey, skip these rows and give me the next 10.
Ah, so it's like fine-grained control over what data is retrieved and when.
Exactly. IEnumerable, on the other hand, is usually working with data that's already in memory, so it doesn't have the same level of flexibility.
Okay, that's really helpful. So if you're working with large data sets, especially in a database, iQueryable is definitely the way to go. Now let's zoom in on some specific LINQ methods for retrieving individual items from a sequence. We've got first, single, last, and their or default counterparts. They all seem to be about getting one element, but the subtle differences are really important, right?
Absolutely. These methods are super useful for finding a specific element in a sequence, but they behave differently in certain situations, and it's important to understand those differences so you can use the right method for the right job.
Okay, let's start with first and first or default. What's the key difference between these two?
So both methods are used to retrieve the first element of a sequence, but first throws an exception if the sequence is empty, while first or default returns the default value for the type if the sequence is empty.
What's a default value?
It depends on the type. For reference types, like strings or classes, the default value is null. For value types, like integers or booleans, the default value is 0 or false, respectively.
Okay, so if you're not sure if the sequence will contain any elements, you should probably use first or default to avoid an exception.
Exactly.
And then we have single and single or default. How are these different?
These methods are designed for situations where you expect there to be exactly one element in the sequence. Both single and single or default will throw an exception if there are 0 elements or more than one element in the sequence. The difference is that, you guessed it, single or default will return the default value if the sequence is empty, while single will throw an exception.
Okay, so it's like enforcing the rule that there should be exactly one element,
Exactly.
and then last or default are just like first and first or default, but for the last element in the sequence.
That's
Okay, so it's really about knowing what to expect from the sequence. and using the right method to handle those expectations. Now let's talk about a way to create small inline functions called anonymous methods. What's the point of these? When would you use them?
So anonymous methods are a way to define a method without giving it a name. They're really useful for creating small pieces of code that you only need to use in one specific place. And you don't want to clutter up your code with a bunch of named methods that are only used once.
So it's like making the code more concise and focused.
Exactly. And you create an anonymous method using the delegate keyword, followed by the parameter list, and then the body of the method in curly braces. You can then assign this anonymous method to a delegate variable and use that variable like you would any other method.
Can you give us an example?
Yeah, so imagine you have a method that takes a delegate as a parameter. You could create an anonymous method right there, in line, and pass it to that method without having to define a separate named method somewhere else in your code. It's really helpful for keeping things clean and organized.
Okay, that's really cool. So anonymous methods are like these little snippets of code that you can define and use right where you need them. And finally, let's wrap up with a topic that can be a bit tricky. Unmanaged resources.
Ah, yes, unmanaged resources.
Now, the source material we've been using describes these as things that are outside of the .NET Runtime's direct control. What does that mean, and why should we care?
So unmanaged resources are things like file handles, network connections, or database connections. They're resources that are managed by the operating system, not by the .NET Runtime.
Okay, and why is that a problem?
The problem is that the .NET Runtime's garbage collector, which is responsible for cleaning up unused memory, doesn't automatically know how to clean up unmanaged resources. So if you're not careful, your application can end up holding on to these resources even after they're no longer needed, which can lead to resource leaks and all sorts of nasty problems.
So it's like your program is hoarding resources that it doesn't need anymore.
Exactly. And this can cause your application to slow down or even crash in extreme cases.
Yikes, that doesn't sound good. So what's the proper way to manage these unmanaged resources?
The key is to explicitly release them when you're finished with them. And the best way to do this in .NET is to use the iDisposable interface and the using statement.
Okay, iDisposable and the using statement. Remind me what those are again.
So iDisposable is an interface that defines a single method called dispose. Classes that use unmanaged resources should implement this interface, and the dispose method should contain the code that releases those resources.
And what about the using statement?
The using statement provides a really convenient way to make sure that dispose is always called, even if an exception occurs. It basically guarantees that the dispose method will be called when the code within the using block is finished, no matter what.
So it's like a safety net that makes sure those resources are always cleaned up properly.
Exactly.
Okay, so iDisposable and the using statement are our friends when it comes to dealing with unmanaged resources. That's really important to remember for building reliable applications. Well, I think that covers pretty much everything we wanted to discuss today.
Yeah, it was a pretty deep dive.
It was. And for me, some of the biggest takeaways were definitely understanding how yield can save you a ton of memory when you're working with large collections, getting a clearer picture of the difference between events and delegates and how to use them safely, and also really understanding the performance benefits of using iQueryable when you're working with data in a database.
Agreed. Those are all super important concepts that any .NET developer should have a good grasp of.
Absolutely. Now, as you continue on your .NET journey, I want you to think about which of these memory management or data querying techniques will be most impactful in your own projects. Every project is different, and understanding these concepts will help you write better, more efficient code no matter what you're building. Thanks so much for joining us on this deep dive.
Got it.
Until next time, keep coding. Have you ever felt like you're wading through this mountain of tech jargon just to understand the basics of .NET?
Yeah, it can definitely feel overwhelming, right? All those terms and concepts can be a bit intimidating at first.
Totally. And that's why we're here today for this deep dive. We're going to get to the core of .NET. And the cool part is we're using the awesome questions that you, our listeners, sent in.
Yeah, it's like a guided tour based on